Hello students. So today we are going to see the subject that is radio frequency and microwave engineering. So from that today we are learning the microwave solid state devices. So I am Madhuri B. Mue from the EC department SIT COE. So let us see the microwave solid state devices. So we know that all the microwave signals are having the very high frequencies, or that all the microwave signals are operating at the high frequency range. So basically there are ordinary devices, that is diode and other things, but they are applicable only for the low frequency applications. Now we are moving for the microwave solid state devices, so that are the somehow different one, because it is capable to handle that microwave frequency, that is nothing but the high range frequency, and they are support to handle high frequency as well as the high power, so that they are categorized specially and differently as a microwave solid state devices. So the special electronic effects encountered at the microwave frequencies. So there are several limit the usefulness of the transistor in the most circuit applications, because they working for that the low frequency applications. So they are replaced with the vacuum tubes for low power applications, and it becomes the impractical. So there is a need of small sized microwave devices and caused extensive research in this area. So the research has produced solid state devices with higher and high frequency ranges. So just we have discussed that nowadays in the micro to handle the microwave frequencies, microwave solid state devices are required. So the new solid state microwave devices are active two-terminal diodes such as a tunnel diode, VRACTOR diode, transferred electronic devices, or avalanche transit time diodes. So in this, they are categorized as there are category of quantum mechanics tunnels as a transfer electronic device, where the electrons are transferred from one conduction band to or one level to the another level. So that is tunnel diode, Gunn, LSF in F and CDTE. Then avalanche transit time, in that impact read, buried and trapped devices are there, and parametric devices, that is VRACTOR diode, that is variable diode is there, and step recovery diode, in that pin diode is there, and also Schottky barrier diode. These are comes under that the microwave solid state devices. So these are some VRACTOR diodes shown here. So that is nothing but the variable capacitors diode. So variable reactor, that is VRACTOR. So it is also known as the VARICAP or variable capacitor diode. So it is referring that voltage variable capacitance, or it is used in a reverse bias, that is PN junction. So designated to explore the voltage variable properties of the junction capacitance. So the junction capacitance depends on that the applied voltage and design of the junction. So junction with fixed reverse bias may be used as a capacitance of fixed value, and with the variable uh, voltage, which will help to that the variable capacitance. So how it is different from the ordinary diode? So an ordinary PN junction diode exists the variable capacitance effect, and these diodes can be used for these applications. So special diodes optimized to give the required changes in the capacitance. So varactor diodes or varicap diodes normally enable much higher ranges of capacitance change uh, to be gained as a result of the way in which they are manufactured. So varactor diode. So the basic of the operation of the varactor diode is the quite simple. The diode is operated under the reverse bias condition, and this is given rise the three regions. So which are the three regions? P region, N region, or depletion region. Okay. So P and N regions are the regions where current can be conducted, and depletion region is the region where no current carries are available. So P and N behaves as a conducting plates and the capacitors, and the depletion region acts as a insulator. Okay, so the varactor diode, that is nothing but the variable capacitor, which is which is only applicable in a reverse bias condition. Means whenever you want to work as a variable capacitance diode, then you have to place that diode in a reverse bias condition. So it will work, the two plates of the capacitor is nothing but the P and N region, and in between that depletion region act as a insulator. So see here this structure of that the varactor diode. So the capacitance of the capacitor is dependent on the number of factors including the plate area. Plate area means the P and N region. The dielectric constant of the insulator between the plates and the distance between the two plates. So in case of the varactor diode, it is possible to increase and decrease the width of depletion layer by changing the level of reverse bias. So this has the effect of changing the distance between the plate of the varactor diode. Okay, so capacitor means the varactor diode. First of all, you have to place in a reverse bias condition. So the depletion layer created, that is nothing but the insulator, and whenever you are going to increase or decrease the biasing voltage, according to that the depletion width is going to increase or decrease, and the indirectly the capacitance of that the varactor diode is going to increase or decrease. So let us see the transmission capacitance. So it was established that there is a region of uncovered charges on either side of the junction. That together the regions make up the duplication region and define as depletion with WD. So the transmission capacitance, that is CT, established by the isolated uncovered charges is determined by, that is transmission capacitance CT is equal to epsilon, that is permittivity, into A divided by the depletion width. So A is nothing but the PN junction area. So permittivity into PN junction area, which is divided by depletion width. So these are the some symbols of the varactor diode. So let us see the varactor diode application. So in many applications where electronically controlled tuning of resonant circuit is required, for items such as oscillators or maybe filters, so varactor diodes are an essential component within the portfolio. Then next is the tuning stage of radio receiver to replace the bulky variable plate capacitor. So microwave frequency multiplications as well as in active filters as well as in voltage control oscillator and radio frequency filters, the varactor diode is used. Then next, varactor diodes used in VSECO, that is variable capacitance oscillators. So varactor diode is the key component within it. Then it is used in a phase locked loop, and it is almost all radio, cellular and wireless receivers. Then next component of our microwave solid state devices is nothing but the P-type intrinsic and N-type. So P-type, then intrinsic material and N-type. So that is nothing but the pin diode. So that the semiconductor structure of the pin diode is shown in figure. That is P-type, then in between intrinsic material is sandwiched between P and N-type. So this type of the pin diode is used as a switch and the attenuator. Then reverse bias, so it will work as a off switch, and in a forward bias it is act as a partially on to on depending on the bias. So gallium arsenide is the intrinsic material we can use. So these are some pictures shows the PIN diode, that is M1083. So pin diode symbol, and here the top metal contact means this is nothing but the structure of our PIN diode. So P plus contact region, this is the P diffusion, and in between that intrinsic region is there, so that is larger depletion region. Then this is the N type, then N plus contact region, and bottom again it is covered with the metal contact. So see here also the structure, intrinsic material is sandwiched between the P and N type of the material. So this is the PIN diode. So let us see the working of the PIN diode. So in PIN diode, I is nothing but the intrinsic, that is weakly doped. So whenever we are placing this PIN diode, again we have to use in a reverse bias condition, because whenever we are required the photo detection application, so at that time when that external light is incident on that the intrinsic layer, so in that there is a recombination process start and the current start flowing from that the PIN diode. Then so this type of the PIN diodes for the forward bias will act as a variable resistors, and in the reverse bias it will act as a photo detecting diode. So as a result of the intrinsic layer, PIN diode have a high breakdown voltage and they also exhibit a low level of junction capacitance. So basically intrinsic material is sandwiched between the P and N region. So these type of the diodes operate in exactly the same way of the normal diode. So as we have discussed in forward bias, the variable resistor, and in our reverse bias, it is act as a photo detector. So the only real difference in that depletion region and normally exists between the P and N region is the unbiased or the reverse bias diode is the larger. So in any PN junction, the P region contains holes as it is has been doped to ensure that it has a predominance of holes. So similarly, the N region has been doped to contain excess electrons. The region between the P and N regions contains no charge carriers as any holes or electrons combine. As the electrons regions has no charge carriers, it acts as an insulator. So within a PN diode, the depletion pressure exists, but the diode is a forward bias so that the carriers enters into the depletion layers, that is nothing but the intrinsic region, and as the two carrier types meet, current starts to flow. So when the diode is forward bias, the carrier concentration, that is holes and electrons, is very much higher than the intrinsic level. So this electric field helps in speeding up of the transport of charge carriers from P to N region, which results in faster operation of the diode. So make it a suitable device for high frequency operations. So here is the operation of the PIN diode is shown. So when PIN diode is forward bias, holes and electrons are injected from the P and N region into the I region. So these charges do not recombine immediately. Instead of this, finite quantity of charge always remains stored and results in a lowering of the resistivity of the I region. So figure A and B shows that the working principle of PIN, that is construction of PIN diode, and equivalent circuit of the PIN diode. So for the lower frequency, there are some limitations while operating with the PIN diode. So at the low frequency, a PIN diode only acts like a rectifier at a low frequency. And at microwave frequency, the IV curve undergoes a change so that it behaves like a resistor whose resistance value is determined by the level of the DC current that is present in the I region. So thus a PIN diode is essentially a DC controlled high frequency resistor. Just as important, if no DC current is present, the diode behaves like an open circuit. So there are some characteristics of the PIN diode. high breakdown voltage, low capacitance, then carrier storage and sensitive photo detection. And there are some applications of the PIN diode. So PIN diode as a variable resistor. So just we have discussed that is in a forward bias, it will act as a variable resistance. Resistance value of PIN diode is determined by only the forward bias DC current. Again, in switch and attenuator application, the PIN diode should ideally control the RF signal level without introducing distortion, which might change the shape of the RF signal. So these are the switches application. So next solid state device is the Gunn diode. See here some pictures of the Gunn diode. So Gunn diode is also known as the transferred electron device, that is TED, which is widely used in a microwave frequency. So that single Gunn diode can generate the frequency between 1 to 100 gigahertz. So which is made up of, if suppose gallium arsenide Gunn diode is there, so it will generate up to the frequency 200 gigahertz, whereas gallium nitride can reach up to the 3 terahertz. Okay, so basically Gunn diode generates 1 to 100 gigahertz, but special type of that the concentration if we made, then it will generate 200 gigahertz up to the 3 tesla hertz. So the Gunn diode is most commonly used for the generating microwave signals. So these circuits may also called as transfer electron oscillators, that is TEO. So the Gunn diode may also be used for an amplifier in the transferred electron amplifier, that is TEA. As Gunn diodes are easy to use, they form a relative low cost method for generating microwave RF signals. So these type of the diodes are used in high frequency electronics. So somewhat unusual, that is consist of only the n-doped semiconductors materials, whereas most diode consist of both p and n-doped regions. So in practice, a Gunn diode has a region of negative differentiation resistance. The Gunn diode is a unique component, even though it is called as a diode. It does not contain a p-n diode junction. The Gunn diode or transferred electron device can be termed as a diode because it does have two electrodes. The Gunn diode operation depends on the fact that it has a voltage controlled on negative resistance. So what is the principle of the Gunn diode? It consists of a slice with a buffer layer between the active layer and the substrate, mounted in any of a number of packages depending on the manufacturer. Then there is a GAS group utexily with the silicon or selenium. The substrate used here and that the ohmic contact is highly doped for the good conductivity. Then diode have been made with the active layers varying in a thickness of 40 to about 1 mm. So the actual structure is normally square, and so for GAS diodes predominantly commercially so these are the this is nothing but the construction of the Gunn diode. So heavily doped N plus material is used. Then it is also heat sink is provided to overheat. Then gold connection is made.